Hi, I'm Noah from Team Maxima, and just before we get too far into it, I would like to explain what we mean by Team Maxima. It's a little double entendre, and it's not what you think. It's not gradient descent.
Can I hear you? A little closer to the mic.
Okay, so just to start it off, I'll have Elder explain where the name comes from.
Yeah, so we picked it in reference of the constructive superposition of waves, as you see here in this image. And so we think it represents our approach to this challenge. For us we all come from different approaches, but we think we collaborated in a way that allowed us to look at the challenge in a new way.
So like I said, my name is Noah Marconi. I'm a researcher turned developer. And my teammates, we have a particle physicist, Elder, and Indrani, we have a big data developer. So we have a range of skill sets that we brought to bear on this problem. And looking at the mentors, we had a lot of help from mentors. So there was actually hours of discussion up front with the mentors about what the core problem is and some of the approaches. And the really interesting thing is that we only had one day to work on it, but there was a lot of opportunity for the future. So even though we implemented something that will show you, there's even more work that could be done later, trying out some of these other approaches and looking at, well, what is the optimal solution within this framework. So what we chose as the problem is the cold start problem in a recommender system. For a little bit of background about what that is, think of Wattpad. So Wattpad has new users coming in all of the time. They have 43 million, I believe, active weekly users. And as they bring on new users, it's a little difficult to recommend who they should follow based on what other users have already done. If you're thinking of a behavioral analysis, when somebody comes in new, you don't have a history of behavior, so what do? And our solution, we actually had two approaches that we worked into one framework. Collaborative filtering, substituting ratings. Instead of ratings, we use similarity. And in this case, we use author-reader similarity, and we use distance as a metric. But like I was mentioning, there's a lot of opportunity in how we could change and edit there. So we could do user-to-user similarity and use that as a weight and come up with a more intricate solution there. So there's a lot of future work that could be done. And the other solution was actually just simply subsetting the audience. Using k-means was our recommended approach. We did run into some computation issues. We ran out of RAM to work through all of it. So we quickly, as a hackathon, so we hacked through and subsetted by age and had some interesting results. So looking at these age subsets, page ranking within each.
So for the data manipulation part, we were actually given a chase.
Pull the mic down.
Pull the mic down. We were actually given a JSON file which had information about all the users and followers. So what we did is we use Amazon S3 and Databricks. So what we use is all scalable and distributed. We've split the JSON file into two parts, one for a data set for nodes and one for the edges, and we built a graph out of it. For this we used the graph frames from Spark, and we have saved these into Sparky files because Sparky files is for the sake of the language interoperability. We have Scala as well as Python developers on our team, and then we've used MLlib for collaborative filtering and k-means. So what's great about this is these are designed to scale, and the Sparky and S3 is for language interoperability. This is how the original schema looks like. So we have information for the followers and the followees. We have age, gender, and if they have at least a 3 reading list. What are the geolocations of these followers or followees, and platform and user language and stuff like that. So this is what the schema of the split files look like. What you see here on the right is of the nodes and then the edges. So anything that comes in later on, like any other information, just gets added on the edges. So that way we don't have to redesign everything, and it's for the sake of having a compact data structure. So like I told you, new follow events only need to update the smaller edges table. So yeah, that's good. So
just a quick note about the schema. Once we rearranged the data set, it actually became very easy to explore. So we took a look at the age distribution. There are a lot of people didn't volunteer their age, but those who did, we saw similar shapes between authors and non-authors, and it gave us something to start talking about. We also did some geographic analysis and found, we discovered, it's the Toronto HackOn data. It was a very Toronto-focused data set, but we did have individuals from other parts of the world as well through the graph connection. So getting into the solution that we applied to the problem was that cold start problem. We understand there's a big impact on the business if you can onboard them faster, just keep them more engaged. That directly translates to, hopefully, increased revenue or longer term success. So the framework we used was modified from something that one of the mentors, Wendy from Wattpad, gave us. There was a Microsoft paper that described a similar recommender problem. They also targeted the cold start issue. It was very involved. They had a lot more information than us, and they spent a lot of time distilling it and coming up with really a very involved system. So we reduced it to some extent. So we focused on follower similarity, followee similarity, candidate followees, and some form of recommendation model. And given that it was a hackathon, we didn't have time to implement everything, so we actually implemented the purple parts. And in this collaborative filtering, Albert will explain the similarity method.
Yeah, so one thing we discovered discussing with the Wattpad mentors was that while the data set that we were provided didn't include any behavioral information about the readers and authors, but it did have mimicked in many ways what you get when you have a new user. And in particular, something that we almost always had was their location where they created their accounts. So we thought that a good start for this collaborative filtering would be to use this distance between readers and authors as a proxy for similarity. So in order to do this, we calculated the distances between them using a simple, fast algorithm, and we found some interesting insights while doing that. For example, most of the authors in the data set were based in the city of Toronto, but we had readers, many in the city, but also widespread all over the world, in particular in the Philippines. So you can see that here. The goal was to use MLB routines for collaborative filtering. So we implemented an ALS model, and in order to get there, we did some additional data wrangling. So for example, we had string IDs that were used to be converted into integer IDs, keeping in mind that we had authors and readers in both lists. So we had to account for that. And also, we rescaled the distance that we calculate to make it simpler for a model. And so we rescaled it in such a way that a 0 would be being very far away and 1 would be very close. And so in this plot here, you can see two peaks. So the peak near 1 are all the readers that are very close to the authors. All the authors are in Toronto, so there's all the readers in Toronto. The other peak, around 0.3, are the readers in the Philippines. So we got the data to the point where we could apply to this ALS model from MLlib, and we're able to get predictions out of it. We didn't have time, given the limited amount of time, to fine-tune this parameter or to evaluate the precision, but we were able to get some predictions. One interesting approach would be in this framework that I presented, we didn't filter our users in any way. One interesting idea would be to filter them only to have local authors and users. And the idea there would be to try to engage local businesses to support local authors by recommending local readers to those authors. So that's something that could be easily implemented in what we've done already.
So the second approach, following the same framework, was using PageRank and segmentation. And we focused on segmenting as our similarity proxy. So if you fall into the same k-means cluster, we would assume you're similar. Again, like I explained, we actually didn't have the computing power to run k-means properly. So we just ran some age buckets. And that was our similarity. If you're in a similar age group, we expect your preferences would be similar as well. And to show the configurability, we swapped out the collaborative filtering and used PageRank for the recommendation. One note before I get too far into it is with the similarity, there's tons of flexibility there. So we did user to author similarity, but we also have user to user similarity. And there's almost too many variations that we could get into, making it a very interesting problem. Same framework, I just want to point out, but very different mechanics. And what we found, again, we do have recommendations that we pulled out for each of these groups. But what we were surprised about is how different they were. I kind of expected PageRank to just give us who's popular, and I thought who's popular, we may fail and find too much overlap everywhere. But if you look at most of the overlap, it's when we don't know their age, it tends to overlap somewhere. When we do know their age, there's less overlap. So if we went deeper, so if we had a higher level of, look at the top 30 or 40, we may see more overlap. But if we're just focusing on the top 8, there's very distinct differences in who we're recommending to these individuals. And we think that has legs. So when you do that cold start, if you start segmenting, possibly using demographics, possibly using other information you have about them, just segmenting and doing your recommendations based on similar groups of people, we think that it'll lead to a lot of benefit. The note here is that one size, sorry for the typo, but one size fits all isn't necessarily the best approach. We think a more fine-grained approach is useful.
No, before we go on, can you go back and can you explain what the colors mean?
Oh, the
Or
colors?
actually explain, or maybe explain the viz altogether. It's
Oh yeah, that's a
hard time understanding what we're seeing.
No problem. So each column is a group. So the first column is total. We threw everybody into the same analysis and ran PageRank. And we came out with these 8 IDs of who somebody should follow based on no similarity analysis. Then we took those with an unknown age, and that's column 2. And then we took smaller age groups. So the young teens, the young adults, and adults would be 19 plus. So we just took different age splits. And we used the distribution to try to get sizable groups in each. Age unknown happened to be the largest group of people, unfortunately. So those are the columns. Each row is just a ranking. So the top row is our top ranked author for that group. And each of those hash codes is the start of the full ID. Because we didn't have a lot of IDs, we trimmed it at 10 characters. And quickly skimmed through and tried to isolate where we're seeing overlap. What I expected to see on first pass is tons of overlap, and I wanted to just pick out some differences to say this had legs because there's some differences. And it was the opposite. It's actually more differences than overlap, which is very encouraging.
And what are the colors represent?
The colors are the overlap that we found. So 5A9717 is blue. So that's that one author that's being recommended across. Yep. And the orange is another author we found overlap.
Got it.
And the major takeaway is we were surprised. We're happily surprised, but surprised. So we did a number of things within this framework. We were using the word earlier, mix and match. So we have this framework, you identify similarity, you run a predictive algorithm. But outside of mixing and matching, there's a lot more opportunity that's very interesting and would love to see it come to fruition. One of the mentors was even suggesting ensemble models. So it doesn't have to be one model per area in the framework. We can actually aggregate and do a number of things in each of those steps. So there's a lot of opportunity on the table to continue improving. And in the future, we have some thought starters as well. We love the usage of the graph frame. So once you get the data into a structure, you have your nodes and your edges, it's very easy to work with. So there's a graph-like query language that we can use, and once we query it, then we're back to SQL, once we have a regular table. So it's very easy to work with, and there's a larger opportunity to make use of the graph. One specific possibility is community analysis. So we're recommending things based on similar groups of people, but what about dissimilar groups of people? I tend to read things, and all of the authors I tend to read, if they're all in the same category or genre, maybe there's a surprise and delight opportunity, showing something new and different by doing label propagation, so out-of-network recommendations. Plenty of opportunity for tuning. That's something we didn't necessarily demonstrate here, but we do want to point out we understand we need to be tuning these models, and also measuring them against real-life results. In the surprise and delight example, We don't necessarily have an offline method of testing how productive that will be, because we're not predicting who they currently follow, we're predicting whether or not they'll enjoy us offering someone new. And then, like the feedback from the mentors ensemble methods, there's a lot of combining of techniques that we could be doing as well. So to bring it back full circle, the business problem with that cold start issue, people come on board, and instead of simulating that behavior by saying, well, which of these authors do you think you like? We thought we could kickstart it by just suggesting people, based on what we know about you, it's not very much, we think you may be interested in these people. And the impact on the business, if we're successful, would be including faster onboarding. So from the time you sign up to the time you have a number of authors you follow, we shorten that time, and we increase your weekly usage. We think that would be a good metric to measure these techniques against. Assuming that if you have increased weekly usage, that hits the bottom line directly in a positive way. So that concludes the presentation. If you have questions in the audience or from the judges, we'd be happy to talk more.
So it was a very Wattpad-centered approach, and used the Wattpad data set, which is awesome. Thank you very much. And you definitely attacked a problem that is near and dear to our heart. It is the single hardest thing on Wattpad is to get a user engaged with the system in the first week, first couple of days, and get them to use it again. We know that the biggest difference between a user who's going to retain and love Wattpad and whether they're just going to use it once or whether they're just going to fall off is whether they actually use it the second time. It's like one usage, you got to get a second usage out of them to get them reading in that usage. So that these are all very relevant things you're doing for Wattpad business, and I think that's great. I think you started mentioning the evaluation, and you said that there's no good way to do an offline evaluation. It feels like there's a lot of opportunity there to try to find ways to do that offline evaluation. Did you explore some methods there to try, or was it a limitation of the data set, perhaps, that you couldn't do that?
It was more a time constraint.
Okay.
That was the reason we didn't apply any offline evaluation. So we did talk a lot within the group. We believe there's value there. It's just when we're talking about introducing authors, they wouldn't have followed anyway, but they would enjoy reading. That's a tricky one because we wouldn't have that in the data set. If they follow within a network, or they follow who other people follow, or they follow within a genre, we should see clusters within the network, communities within the network. If we're trying to break out of those communities and introduce them to something new and different that they may also enjoy, their current behavior wouldn't tell us if we hit the mark or not. It would actually have to be, you could even do it on a small qualitative scale, pick a group of 10 people, show it to them. These are new and novel. Is this off-putting? Are they too far away from what you like? So that was the point of the offline, is that we think we need a new approach to testing it if we're doing that surprise and delight.
Does it feel like the standard method would be to hold out and some of those results and say, well, we know these people follow these authors, let's hide those authors from the system and see how good it is at predicting them. Is there any reason why you wouldn't use that method?
For the onboarding, there's no reason why we wouldn't do that for the onboarding. It's further down the line, trying to increase even greater out of network. So that comment, I may not have phrased it very well, but it's in the future opportunities. Once we have this graph, there's a lot more, there's new problems we could tackle, and new angles, new solutions we could try.
So I just echo Jerome's sentiment. This is also a problem that we have at Flip. How do you a cold start user who doesn't know your product, hasn't interacted with it enough, and therefore you're not learning a whole lot from them. Going through this exercise of defining ways of alleviating the cold start problem. Did you learn anything maybe that might suggest how the product might be reformulated to increase your learning faster with the user?
Personally, yes. And I'm not sure what's actually been tested. So a lot of what I would suggest, I would immediately recommend doing a very small scale test, qualitative usability, or roll it out to a small group. But I downloaded the app yesterday, or today even, with a new user account. And the first thing it had me do is fill out a little bit of information about myself, which is great. And then it asked me to start indicating things I think I would like. And I don't know who I would like. So from a user interface standpoint, if there's a way to phrase that differently, or to make it seem less daunting, I don't want to click on the wrong thing and then have your recommendation engine start suggesting things I'm not going to like because I wasn't informed of that. So is there something, can I read a snippet, possibly? So there's a lot of user interface approaches or small scale tests, edits that you could do to present the problem to the new user differently. As far as the algorithms go, yeah, I think even one thing we were talking about is locally. This is actually a lot of the discussion we had up front. So that's a 20-minute mark, but a lot of the discussion we had up front is how could we approach this problem, and how should we formulate the problem or the success metric. And when we were talking about the local authorship or the local following, so if you have an author in Toronto and we set out to increase their readership, maybe we could dedicate a portion of the UI to just that. You live in Toronto, how about you check out some local content? You're interested in these things, how about you check out some related content? So if you have different approaches to recommendation, you can even present it to the user saying, here's how we came up with these recommendations. You pick what you think is appropriate for this time. And that came actually a lot through, we spent a good couple, we got worried, we spent a good couple of hours talking to mentors, and then we panicked that we didn't have enough time to implement it. So the three of us talking, I think, was a very useful exercise, and then bouncing ideas and having that brainstorming session with a range of mentors was incredibly helpful. Any additional questions?
So before arriving at the cold start problem, what other business problems did you consider when tackling the Wattpad challenge?
Do you want to talk about the
Well, yeah, like before arriving, like I would imagine that you sit down as a team and say, well, there's the cold start problem, and maybe there's a couple of other problems. And so, what other problems did you consider, and what was the decision making that led to the cold start problem? If that was kind of the process.
I think our process initially was just to do an initial exploration of the data, and I think what we realized was that a lot of the features were missing for many of our entries. And we found that the location wasn't. So we thought, oh, we should use it somehow.
It was like a platform and you can so we were selecting what was. So all of you left with us after we got left in a world
And so, what were some of the key insights you derived from this data exploration that were kind of, I guess, a deciding factor on choosing the gold star problem? Were there any trends or completeness of data, or?
Well, it was a mix of what we have in the data and the discussions with the mentors as well. So some of the mentors are from Wattpad, so we can pick their brain and say, well, here's what we're thinking. Here's the range of topics we could cover. What's actually near and dear to your success as a company. So those conversations on both ends, learning about the business behind the data was very helpful. As far as the data goes, there's a lot we could have done if we had more information. Predicting, we're actually looking, as soon as we saw the library data, we thought, oh, this is great. We can compare what people currently read in terms of genre, and maybe look at the library data. If there's something demographically in there, we can do a big profile or link the two together. But we didn't have that in the data set, so we started, really the data set was a follower-followee relationship, and that narrowed us into a recommender system. And then talking it out as far as recommender systems go, blindly applying collaborative filtering didn't raise any eyebrows, no, it was particularly exciting. We're doing a twist on that, where we're not necessarily using just the relationship, we're using the similarity. That was quite interesting, and different ways of segmenting and even introducing page rank started to get interesting. So we took a step back and used that they framework